Well, this is it, our second to the last section, called Contingency Tables. So the idea is we're going to test if two variables are independent. Like, how about the amount of money that somebody makes? That's going to be one variable. Their gender, that's another variable. So does gender have anything to do with the amount of money that people make? Well, in general, unfortunately, it's true. There is a relationship between gender and the amount of money people make. So, what if it was the way that a person votes and their gender? So with this one, notice that there's no numbers. With a person voting, they're going to say, hey, here's a person. Would you vote for them for president? Somebody's going to say yes or no. It's not a number. Also, gender is not a number. So we can't do something like linear correlation or something like that we've done in the past. We need something new. That's what I was just saying. So there's no numbers. So what we're going to do is organize the information in a matrix. In statistics, they call it a contingency table. Is one variable contingent upon another? So, for example, would you vote for Joe Biden? Out of 120 women, 45 said yes. Out of 150 men, 80 said yes. Okay, so the claim is that voting for Biden, that's one variable. Do you vote for him? Yes or no? And the person's gender, those things are independent. And here's the data that I just said. So organize that in a table. So on one side, we'll have the gender, men and women. On the other side, would they vote yes or no for Biden? Now, these were both yeses. So for women, there was 45 yeses. So for women, 45 yeses. That's this 45 right here. For the men, 80 yeses. So 80 goes right here. Then I need to subtract. For the men, it would be 150 minus 80, so that's 70. That would be no. And for the women, 120 minus 45 would be 75 that said no. So that's the contingency table. Now what we need to do is put this information in the calculator, which I'm going to show you in this other video. I'll be right back. Okay, let's use the TI-84 to enter this contingency table. So first of all, over here on the left, it says matrix. And you need to put second matrix. And then just leave the cursor on 1 for A and move over to edit. Hit enter. And there's the matrix. Now, if you haven't used it before, it may not say 2 by 2. So it's got 2 rows and 2 columns. So this one is 2 by 2. If it doesn't say it, just press 2, enter, 2, enter. And then it will make a, if you haven't used it before, it will just make a matrix with zeros. And then type these numbers. So I've got some numbers left over from another problem. That doesn't matter. Just start typing 45, enter, 75, there's the first row, and then 80, enter, 70, enter. There we go, there's the matrix or the contingency table. Now to do the chi-squared test. So you go to stat, over to tests, and then it's almost at the bottom, scroll down until you get to that one that says chi-squared test. When you hit enter, it's supposed to say observed values are in matrix A, so this is called matrix A. That's your job to type in the observed values in matrix A, and the expected values are going to go in matrix B. So if somebody was messing with their calculator and they erased that, then all you do is put the cursor on that, go back to matrix, second matrix, just choose B right here, and now it's back. The color doesn't matter, move down to calculate, and there's the test statistic. So it's going to be that chi-squared equals 6.722. And degrees of freedom is the number of rows minus 1 times the number of columns minus 1. Well, this has 2 rows and 2 columns. So this is going to be, degrees of freedom is 2 minus 1 times 2 minus 1. So that would be 1 times 1. Degrees of freedom is 1. And the calculator was also able to figure that out right there. Now, one other important thing is go back and look at matrix B. So these are the expected values, which means that if them saying yes is independent of their gender, this is what we would expect to see. So you go to second matrix, then choose matrix B, and you just have to verify that all these numbers are bigger than 5. If they're not bigger than 5, then the results of the test are not going to be reliable. As you can see, all of these are way bigger than 5, so the results are going to be reliable. And we got the test statistic is 6.722. So you just go to table A4, use degrees of freedom as 1. It's a right tail only test with alpha equal 0.05. So the critical value is 3.841. Well, a 6.7 definitely goes to the right of that, as you can see with my fancy arrow right there. So that means reject the claim of independence. So according to this data right here, this little survey, somebody's gender and how they would vote for Biden, they are not independent, they are dependent. Because it looks like the women are saying no at a much higher rate than the men, or the women are saying yes at a much lower rate than the men. And as I showed you on the calculator, all of the E values are above 5. That means the results are reliable. Now let's do one more. How about testing the claim of independence between gender and the balance on a Visa card? So here is a whole list of data. Notice that it's already been separated. Here's the men, and then here's the females. So men and women divided at this line right here. So when I make the table, I'll use men and women, and I need to know how many men and how many women there are. So just start counting those, and I'll show you that in just a second. Next, find the median. So take all of the balances for everybody, and find the median. Well, I did that on a calculator, and it's 624. So I don't really feel like using 624, and I'm just going to use 625. As long as it's close, that's fine. But the number 625, as I search through this list, I can keep 625 in my mind better than 624 for some reason. So I'm going to use 625. So count everybody with a balance under 625. So that would be like this one, 235, 122, a 0, an 84, etc. So when I did it myself, this is what it looks like. First, divide. Here's the men, here's the women, and I counted there's 19 men and 16 women. And then I just put a check mark for anybody whose balance is under 625. Under, etc. Now it turns out that there's 9 men and there happens to be 9 women whose balance is under 625. Now organize this in a table. So those that are under 625 and those that are over. So like I said, there was 9 men, so that's this 9 right here, 9 men whose balance is under 625. For the women, there's 9 of them whose balance is under 625. And if there's a total of 19 men, then there must be 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Yes, 10 of them whose balance is over 625. And since there's 16 women and 9 are under 625, that would leave 7 over here. So then use the calculator. And with this, I'm just going to show you screenshots rather than creating a whole new video for that. So I put the numbers or the matrix in matrix A, then do the chi-squared test, observed in matrix A, the expected in matrix B, and then it turns out that chi-squared equals a 0.274. And again, degrees of freedom equals 1, and so it's going to be the same critical value as last time, 3.841. And with a 0.27, that lands way over here to the left. It does not even come close to the 3.841. So this one failed to reject the claim. In other words, we cannot prove anything. Basically, this is saying there is pretty much no difference when comparing men and women. You can't say that women owe more or men owe more on their credit card. There's almost no difference.